Alrighty, guys. So our next topic is this thing called significant figures. Now, significant figures really just applies to numerical values, so any numbers that we see. So I'm going to write a couple numbers down, and I want you guys to just think about how many significant figures might be in each of these. So we'll write down, like, let's just say 5 numbers, and these are just random numbers that I'm thinking of off the top of my head. And let's see if we can just get the correct number of sig figs. So take a minute, think about what sig figs might mean. It could mean all the digits added together. It could mean the number of digits. It could mean just about anything you guys can maybe think about. Think about the word significant figures and think about what that might mean in terms of how many significant figures each of these numbers has. So I'll give you guys a second here to think about it. And so now I'll write the sig fig number next to it. So the number of significant figures it has. And so our first one has 4 significant figures. Our next one has 2 significant figures. So far, think about what that might mean now. And our next one has 3 significant figures. Our next number has 6 significant figures. And finally, our last one has 1 significant figure. All right. So now that you guys have kind of seen this a little bit, let's talk about some of our rules, because I think the number of significant figures will make more sense once we actually see some of our rules. And so our first rule in terms of determining the number of sig figs is non-zero digits always count. And so when we say non-zero digits, we mean basically 1 through 9. Any of those numbers always count. So for example, 555 has 3 significant figures. And 7 let's just say 4 is 2 significant figures. All right, now let's talk about our next rule. And our next rule says leading zeros, meaning numbers that start with 0. So leading zeros that come before, and I got to erase some of this. So leading zeros that come before non-zero digits never count. And so what that means is, let's just say we're talking about something like 0.02. This only has 1 significant figure, the 2 being that one that's significant. So the first 2 zeros are not. And let's look at another one like 0.0025. This has 2 significant figures, being the 2 and the 5. So those first initial 3 zeros don't count. So these are our first 2 rules. Now let's get into our next 2. And so rule number 3 says captive zeros, and you guys will notice a trend here. It's all about zeros. Captive zeros, meaning zeros that are trapped between 2 numbers. So captive zeros between non-zero numbers count. Ooh. And so that means that if we have a number like 101, this is 3 significant figures. And if we have a number like 0.0505, this also only has 3 significant figures, because remember, rule 2 says the first 2 zeros don't count, but then after that, we have a captive 0 trapped between the 2 5s. Then rule 4 is about trailing zeros, and rule 4 says trailing zeros only count at the end of a number if there's a decimal point. And so what that means in terms of our example here, if we have something like 100, this only has 1 significant figure. However, if we put 100 with a decimal point, this becomes 3 significant figures. Now, this rule is kind of tricky too, so let's talk about a couple other examples. Let's just say we have 100.0. Now, because of that decimal point, this becomes 4 significant figures. And if we have, let's just say something like 10.00000, all of these zeros are significant because of that decimal point. So that means that we have, in this number, 7 significant figures. So I know that one's kind of a tricky rule. And finally, our last rule, which is also a little tricky, our last rule says exact numbers from counting and definitions, and we'll talk about what this means in a second. So exact numbers from counting and definitions have infinite number of sig figs. And so when we're talking about what that actually means, let's say we have 2 examples here. So one from counting would be like if we said there's 3 books. You can count exactly 3 books. And so that means that this is a number that has an infinite number of sig figs. Now, another example that we're going to talk about a little bit later on today is the idea of these conversion factors. And so we talked a little bit about it with the metric system, saying there's like 100 centimeters in 1 meter. That's also an example of something that has an infinite number of sig figs. Now, this rule 5 here, this really applies more to calculations than it does to counting sig figs, just so you guys know. And so when we talk about calculating with sig figs tomorrow, then this rule 5 will play a much bigger role. Otherwise, let's look at some examples of how we determine sig figs for our numbers here. So go ahead, think about our first couple. And so we got 950 with no decimal point. So remember that says that goes back to our trailing zeros. And so our trailing 0 doesn't count because there's no decimal point, which means there's only 2 sig figs here. Then our next one, we got 0.45, also only has 2 significant figures because remember the leading 0 doesn't count according to rule number 2. Then we have 0.450. Now by adding this 0 after this decimal point, that does mean it is significant because there's other non-zero digits in front of it. So that means that this has 3 significant figures. All right, now our next one, 890 with a decimal point. Because of that decimal point, that 0 does become significant, meaning we have 3 sig figs here. Then next up, we have 803. And for 803, again, 3 sig figs. Then we have 3.43, 3 sig figs. And then finally, for our last two, we have 0.0000004. Now remember, all of those are leading zeros, so those don't count. So that means that this number only has one sig fig. And then finally, our last example here, we got 0.007500. And so when we're looking at this one, take a second, think about it. And hopefully you agree, this number has 4 significant figures. Remember, these leading zeros don't count, but these trailing zeros do because of that decimal point. All right, so that's it for sig figs. Now let's talk about how sig figs actually relate to the idea of measurement. And so one of the big things that you're going to have to do in science is take measurements. And so your measuring should always have certain digits, meaning numbers that you're confident in, plus one uncertain or estimated digit. So for example, we have this strip of paper here, and we have this measurement system. Let's just call it a ruler. And so our question is, how long is the strip? Now, as we're looking at our scale here, we can see that we're certain that the strip is at least 30 centimeters long. Centimeters coming from our unit over here. Now, for our uncertain digits, this is where we estimate what comes after the 30. And so this would be our ones place as what we're estimating. And so the length of our strip, and here we'll even label this, the length of our strip would be what we're guessing this comes down to. So as I draw my line down, to me, that looks like it's probably about 34 centimeters. So let's look at another example where our system or our measurement system changes a little bit. Ooh. And so if we're looking at our next measurement system where it changes a little bit, here we have, again, another strip of paper. And so as we're looking at it, we're certain all the way down to the ones. And so what that means is our uncertain digit, we're guessing the tenths. And so since we're guessing the tenths, that means that as we come down here, we kind of look at it, and to me, we're confident in saying that it's 11, but it's 11 point something. And to me, that looks like it's about 11.2 centimeters. So if it helps, the idea is that significant figures in measurements are all of the known digits, like meaning the digits we know for sure, plus one digit that's estimated. And so when it comes down to kind of thinking about it, that means that let's just draw blanks for our numbers. Decimal, blank, blank, blank. So as we're taking measurements, if we're confident in saying that we can measure this spot, like we have a scale that goes all the way to that spot, that means that this is the one that we're estimating. Whereas if we're confident in saying we know to this spot, that means that this is the one we have to estimate. Now, an important thing here is that even if it's, let's just say, right on the line. So instead, this strip of paper was right here is where it ended. So that's the length of the strip of paper. And it looks like it's right on 11. We still have to estimate that tenths place. So if this was our strip of paper right on 11, we would call it 11.0. So yes, even if you're estimating that the last digit is a 0, it does still need to be included. All right, so now let's talk about how we measure with graduated cylinders, because this is going to be something that we're going to have to do a lot. And so as we're measuring with our graduated cylinders, obviously, what can you measure to on this graduated cylinder? Now here we see that this long line represents 5, this long line represents 10, and then we have 4 tick marks in between, which means that we can measure all the way down to like the confidence, meaning we know the ones place. which means that we have to estimate the tenths place. Now, anytime you're measuring in a graduated cylinder, we have this curve of our liquid. Now, for that curve, we always measure to the bottommost spot. And so that bottom spot is known as the meniscus. And so as we're reading our volume here, we see that this is 5, here's 6, and let me erase some of the lines that I drew a little bit so we can get a better estimate. So 5, 6, here's 7, so it's in between 6 and 7. And so we would call this 6.5 milliliters. All right, so let's look at one more example here. And so for our last example, here's our graduated cylinder. And I'm actually going to give you guys a minute here. So pause the video. Go ahead, take your certain amount, your uncertain amount, and then the actual volume of your liquid. So go ahead, hit pause, and give it an attempt. All right, so now that you guys have tried this out, for our certainty in this one, since this is 1 milliliter, this is 2, we're certain all the way to the tenths, meaning the first number after the decimal point, which means that our uncertain amount is the hundredths, meaning 2 decimal places. And so as we're looking at this, we see that it's 1, it's a little bit above that, but it's below the 1.1. So we would call this volume of liquid something like 1.04 milliliters. Now, just so you guys know, in terms of measurement, it's how you see it. Is the important thing is the fact that you're going to the correct number of places. So I called this 1.04. If you called it 1.05, that's okay. If you called it 1.06, that's okay. The important thing is that you're estimating to the correct number of digits, meaning your uncertainty value is being recorded. All right, that's it for this one.